Okay, this is the time for us to start the session. Let's just wait for 5 minutes so that other people also join in. Hello everyone. If any of your friend is interested to know about formula, vehicle design and dynamics, please ping them, share this particular link with each of your friends and ask them to join this session. We will be starting today's seminar just in next 5 minutes. During this time, we will be waiting for the other participants to join as well. Let's just wait for 5 more minutes so that other people can also join in. Okay, I will be requesting each one of you just to stay here. We will be starting the session exactly at 8 p.m. Till that time, if you have got any of your friends who is interested to know about Formula Vehicle design and dynamics, ask them to join today's session. Share the link of today's session with each of your friends. If you have not subscribed to our channel yet, I would be requesting each one of you to please give us a subscribe. This will help you understand the dynamics of motorsports engineering and technological product in a better way. We will be beginning today's session in next 2 minutes. Okay, so we have got 20 plus members, almost 25 members joined in who is watching this video live. I would be requesting each one of you, if any of your friend has enrolled for today's session, ask them to join now. Okay, we have got 27 members. If you have not subscribed this YouTube channel, please give us a subscribe. Okay, could you people please confirm who is here? Like, you can write down your name in the chat box. You can write down your college name, or if you're a part of any student motorsports team, please write down the name of your college team. Okay, within a minute, we will be starting the session. So I believe no more people are joining in as of now. Okay, so this is the time for us to start the session officially. Thank you so much everyone for joining up with today's session. I do not know how many more members are going to join with today's session, but whosoever is present here, let me just commit one thing to each one of you. These 2 hours are going to be the essential learning hours for each one of you. We will be discussing about each and every imperative that is required to design a Formula vehicle. It is literally impossible for me to concise the entire topic of Formula vehicle design or development in 2 hours. It's literally impossible, but in these 2 hours, over my experience of working into this industry for the last 8 years, I will try to give you the exact step-wise process which you people need to look up while starting your journey in the field of student motorsports or in the field of Formula or Supra design. Thank you so much everyone for joining up with today's session. So this is the time for me to start this particular session. In the coming 2 hours, we will be discussing about the process that is needed to be established while designing the vehicle or a Formula vehicle. Over that, we will also be looking up into the parameters that are very much essential with the design and development of Formula vehicle. This particular session is going to be a bit different than the last 2 sessions that we have covered in the previous 2 lectures. Okay, so let's begin the session now. Hello everyone, my name is Abhishek Jain. I'm the founder director of ARC Global. We have been working in the space of student motorsports for the last 8 years. We provide trainings, workshops, and everything essential that is required to bring the student out of the confines of their classroom. If you are a student team planning to participate in any kind of student motorsports event, but has got no hint who will help you out in understanding how the vehicle is needed to be designed, simulated, or is needed to be developed, then ARC Global is the one-stop solution for each one of you. We provide the complete range of solutions in the field of student motorsport. So even if you plan to design or develop a go-kart, ATV, Supra, quad bike, e-bike, solar kart, or whatnot, ARC Global has got those training program solutions available for your student team. If you do not know where to get these custom parts manufactured on the basis of the designs that you people have prepared, ARC Global has got a complete manufacturing facility available in the heart of Noida, where we manufacture all kind of custom parts for your racing vehicles. Feel free to join our community of student motorsports. So thank you so much everyone for joining up with today's session. So let's discuss how you can explore this particular journey of developing or designing a Formula vehicle. So let's start the discussion now. We have got 30 days internship come training program that is open to all the students. So if you are a person who has just completed the 12th standard of education, if you are already engaged into any kind of student motorsports team or the event, if you are a member of any engineering community, this particular internship come training program is going to be the quintessential session for each one of you. In 30 days, there are going to be 4 different modules, and you people will be taught about all the basics to the advanced level understanding of vehicle dynamics, CAD, CAE, automobile engineering, or electric vehicle. So we have got 4 different internship come training program: the CAE internship, 30 days program; CAD internship, 30 days program; 30 days program on automobile engineering, where we also discuss about the CAD and CAE associated with the vehicle design; and 30 days program on electric vehicle design and dynamics. I would request you people to please check our page, our website, achillesracingclub.com/internships, and find out the details about each of these programs. Moreover, you can also reach out to us on this particular number, where you will be getting the complete details of these programs every Monday. Every Monday, a new batch starts into this particular domain. If you want to join us, you can join our upcoming batch, which has just started today. You can join that batch tomorrow. Or if you want, from the next Monday also, you can join the upcoming batch on any of these technologies, on any of these technologies. Call us, drop us a message on Instagram, drop us a message on WhatsApp, and get the complete details about this particular program. So thank you so much everyone for joining up. Meanwhile, you can also think of following us on Instagram. We are available on Instagram with the name of underscore ARC Global, with the username of underscore ARC Global. Find us on Instagram. We have got more than 1,000 followers now. Okay, let's begin the session now. So before I actually begin up with the technical content of understanding how the vehicle is needed to be designed or is needed to be developed, I want you people to go to the lighter content. I want you people to understand what do we actually mean by formula. For that, I've got a very small presentation for each one of you to showcase you why formulas are important, why formula vehicles are important, and how you can also start your journey into the formula vehicle design and dynamics. Let's begin our journey now. This is how the formula vehicle looks like. Not now, about a decade ago, or 2 decades, 3 decades ago, this is how the formula vehicle used to look like. Whenever we talk about the Formula vehicle or a Supra vehicle, these are the kind of special purpose vehicle that are considered to be the paramount structure of racing vehicles. The Formula One racing officially began in 1950, though it has been claimed that the Formula One was available way before 1950. But officially conglomerating all these championships together, we can say the Formula One officially started in 1950, which is organized by FIA. The very first Formula One racing was organized in Silverstone's racing track in United Kingdom. Now you can also see in the entire calendar of Formula One, every year there are going to be 20 to 22 races. Formula One is also considered to be one of the most luxurious sport available in the world. also considered to be the sports of riches. Now, this is something that is changing. Even in India, Formula One is getting popularized. If you people have not watched any of the season of Formula One on Netflix, I would recommend you people right after the completion of today's session to go to Netflix and watch. There are 6 seasons of Formula One there. Watch any one season of Formula One where you will be getting the complete details about the drivers and how these races are being conducted. Formula One race is not just about the speed. Formula One race is not just about winning or losing by a racing vehicle. It is the race of engineers. It is not the race of individual like Lewis Hamilton, Max Verstappen, or anybody else, George Russell, or anybody else. It is the race of engineers. It is the race of constructors. If you watch that particular series, you will get to understand how much pressure a team should have to go through. And if I do not just mimic the racer who is driving the vehicle, just think about the team which is required to design and develop the entire vehicle over a time period of 1 year. Configuring these vehicles separately for all these 20 to 22 races which this particular vehicle should have to go through. You will get to understand about the technicalities that are involved into the design and development of such a racing machine. Formula One will get you understand how actually engineering works. Now, if I just talk about some of the facts that are associated with the Formula One, you will get to know that whenever we talk about the Formula One racing, many of the facts associated with Formula One sums up or feels like the unhuman activity. Sums up or feels like the unhuman activity, inhuman activities. They are so professional, they are so fast that you would be thinking it's not possible for a human to perform such kind of achievement or should be able to achieve such kind of feats in their lifetime. This is what you will be finding out if you look closely into how these Formula One races are being conducted. I will be discussing about some of these feats in the later segment of today's session. You will also find out in the official Formula One races, it is not just about the racing driver, it is also about the constructor. So there are going to be two championship trophies, one for the constructor and one for the individual driver who is driving the vehicle. Undoubtedly, the driver should have to be trained and they should have to be exceptionally talented and hardworking to be the Formula One racer. At the same time, it is not just about how fast you can drive, it is also about how fast your vehicle can corner on the racing track. We will be discussing about these things as well. Okay, so just look up into this entire segment. We came up with some really cool pictures for you people to understand how this thing works and get a bit of inspiration about Formula One. So even on TV, even on internet, when you look into Formula One racing, you will find that the entire Formula One pictures have been showcased in such a in such a I would say hyped way that makes you feel that how rich this particular sport is. I will be breaking down the complete formula for you people today. We won't be discussing about the Formula One, the facts and figures associated with it, but we will be discussing about the design and dynamics associated with Formula One. Ayrton Senna is considered to be one of the greatest Formula One drivers who met with a tragic accident onto the track in 1994. Other than that, I believe you must have all heard about the Michael Schumacher or Lewis Hamilton, the current legends of Formula One. Though Ayrton Senna holds a completely different position in the hearts of people who worship Formula One races. So let's see a very quick memes on Formula One races.
Here is why the average human couldn't drive an F1 car. The reaction time of an F1 driver is around 200 milliseconds, with a record reaction of 40 milliseconds set in 2019 by Valtteri Bottas. This is the kind of reaction time that allows cats to not fear snake attacks. The brake pedal in an F1 car requires 100 kilograms of force to fully utilize the brake power. Additionally, during braking, an F1 car generates a 5G of force on the driver, which is similar to landing a 2-story jump. The driver's neck is the most strained, making the loads on it equivalent to the head weighing 40 kilograms kilograms, which is why some F1 drivers have such a large necks. During a race, the cockpit of an F1 car can heat up to 60 degrees Celsius, virtually melting 2 to 3.5 kilograms of fluids from the driver and causing an F1 driver's heart rate to remain at 170 to 180 beats per minute for the 90-minute race. For comparison, Eliud Kipchoge, the world record marathon holder who can run 42 kilometers in 2 hours, maintains a heart rate of 160 to 170 beats per minute during that time. Let that sink in.
Formula One cars have a pretty cool piece of technology called the DRS. The system moves the flap on the rear wing, which sheds a lot of downforce but also a lot of drag. When active, the DRS increases the car speed between 10 and 30 kilometers an hour, increasing the chance of overtaking a slower car. Other racing series have used a push-to-pass system, which increases the engine power or electrical power in order to help the car overtake. But the DRS system is superior in quite a few ways. Because aerodynamic drag is the main issue, we would require a huge amount of power just to increase the top speed a couple of kilometers per hour. And this would just consume more fuel or energy. And the DRS system is pretty clever because it reduces drag, which also reduces fuel consumption or energy consumption. Now, a lot of people think the DRS system in Formula One is a little bit too artificial because it makes overtaking too easy, but this really isn't the case. The overtaking car still needs to have a substantial pace difference in order to get the overtake done.
Okay, the last video for you.
Box, 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 box. And box, box, box. So you're following Lewis in. Okay, don't make me lose time then.
I think let's take that risk of a double stack.
Well, they are double stacking because Bottas is coming into the pits as well. He's waiting and they have got this absolutely spot on. Valtteri Bottas didn't have to slow down any more than he was required to with the 80 kilometers an hour speed limit. That was proper perfection. Just when one went out, the other one's ready to go. Back in again, but production.
The choreography of that is sensational.
All the four wheels removed, complete vehicle fueled up, just in a second or two. Do you think it is possible for any human to perform it? Do you think it is possible for humans to do this thing? But it is very human. It is very human. Formula One always sets these standards high for people to understand that this particular thing is also possible. So let me just give you let me just tell you about certain facts associated with the Formula One. And then we will be looking up into the technical parameters required to design and develop a Formula car. So let's move up with the content now. So whenever we talk about the Formula One cars or Formula One races, there are a few of the inhuman facts that we should have to look up to. The very first thing is associated with the driver. Do you know, if today I think of becoming a Formula One driver, is it possible for me to become so or to do so? It could be possible. It could be the possibility, but you will find out that Formula One drivers are one of the fittest or few of the fittest humans available on earth. Formula One drivers are few of the fittest possible humans available on earth. Yes, my dear friends. Whenever a driver is asked to drive the vehicle, there are more than 5G of forces acting on their body. What do you mean by 5G of force? 5G means 5 times the weight of his own or her own body. 5 times the weight of your own body is acting just on your neck. Think about this thing. So whenever you are taking the very high speed corner, just think of it that you are moving a vehicle at a speed of 300 kilometers per hour, and suddenly you see there is a corner coming up. You apply the brakes and you took that particular corner at a speed of 170 kmph or 100 kmph. Just saying, such a high turn is needed to be taken up, such a high tight corner is needed to be taken up at a speed of 170 kmph. How many forces are going to act on your body? The centrifugal forces, the G forces acting on your body exceeds the total weight limit more than the 5 times of your body. And all this weight is not just going to act on the entire body, but mostly is going to be concentrated on these hinge points, on these joints, that is on your abdomen, on your neck. Now say, if I say this is my neck and I apply the load of 10 kg, 20 kg on my head, would I be able to sustain this much of load? My dear friends, Formula One drivers can. And that is not just going to happen for once or twice or thrice or 4 times or 5 times in the entire race. It happens on every few seconds. It happens in every few seconds. For a prolonged race of 2 hours or 1.5 hours, the driver should have to witness these count of forces on his or her body for endless times. Yes. Okay. So if today I ask you that go and purchase a car from the marketplace. So say for example, I give you a particular task that I have got certain amount, or you have got any count of money in your bank account, but you cannot just use that money. You can only purchase a car. So there are two different people. Say for example, there is Abhishank and there is Mr. XYZ or Miss XYZ. So Abhishank just shows that if I have got the unlimited money and I can only purchase one car out of it, I thought I will be purchasing the Formula One car. And Mr. XYZ said, okay, if I've got the unlimited money in my bank account and I can purchase only a single car, I will try purchasing, say for example, Bugatti Veyron. Very good. Now, Abhishank has got a car whose top speed is only, sorry, say for example 370 kmph or say for example 350 kmph. Okay. But this particular guy or the girl XYZ has got, say the guy, okay, this particular guy XYZ thought of purchasing Bugatti Veyron, which has got a top speed of 437 kmph. Oh my god. If I just consider this is my velocity 370, then I can say this car is almost 67 kmph faster than mine. And the engine that is used in the Formula One car is almost half the capacity of the engine that is used in Bugatti Veyron. I'm not sure, just check this particular data. It means the engine capacity of this engine is lesser in comparison to this particular engine. So undoubtedly, if I take both of these cars on a racing track, you can definitely say that Bugatti Veyron is going to win the race against the Formula One car. Am I right? Am I right? We can easily say this thing, right? We can easily say this thing. But my dear friends, you will be surprised to know this thing. If I take both of these cars onto the racing track, you will get to know that only the Formula One car is going to win the race against the Bugatti Veyron, and that too not by a small margin but a greater margin. A vehicle having the engine power lesser in comparison to the world's fastest and the most expensive, one of the most expensive cars. A vehicle having the top speed lesser in comparison to the world's fastest possible luxury car. And still, if I take both of these cars available on the racing track, you will find out Formula One vehicle is going to win the race against this particular car. How is it even possible? Now see, when I say this particular car, Formula One car, whenever I talk about this thing, please remember this is a specially designed vehicle for race. A specially designed vehicle for race. Now just look up into this thing. In Bugatti Veyron, there is an engine. Okay. Now this engine is considered to be the power source. Now this is one of the most luxury car or the supercar available in the marketplace. The power produced by the engine will be used to run the wheels. Okay, and then you will be having the world's best possible lights. Oh my god, not just the interior but also the exterior mandatory lights. Okay, you will be having some of the best possible music system available, one of the best possible music system available. You will be having a very good air conditioner. Oh my god, I just felt the air and the breeze of my air conditioner here. Okay, then I got some very good things. Say for example, I've got a very small refrigerator inside it, some cool automated mechanisms inside it. Now my engine is producing power. Some of this power is going to run the wheels and some of its power is going to run the lights, music system, air conditioner, refrigerator, automated mechanism and whatnot in my vehicle. Okay, so say for example, if I have got say 1 kilowatt of power being produced, 500 is going to run the wheels and 500 watt, and 500 watt is going to run this particular item just to make you feel more comfortable. Oh my god, very good. Now in Bugatti Veyron, when I'm seated okay, just like a king. I'm seated just like a very good interior, as well as if I talk about how the driver is going to be seated inside the vehicle or inside the cockpit, it's really amazing. It's really amazing. Okay, very good. If I talk about the Formula One vehicle, you can say Formula One vehicle is the world's costliest vehicle available into the marketplace. Why? Say the single piece cost could be lesser in comparison to some other luxury car or supercar, but the kind of money that is involved into the entire development of the vehicle is much higher, is much higher for a single machine. One of the, not one of the, it is the most expensive vehicle. But despite being the most expensive vehicle into the world, at present you will find out that the engine capacity of this particular vehicle is not going to be as greater in comparison to the engine capacity of this vehicle. Even the top velocity of this particular vehicle is going to be not as greater in comparison to this particular vehicle. Okay. You will also find out whenever the driver is seated into this particular vehicle, Bugatti Veyron, he or she is very comfortable. Oh my God, very happy. But if I talk about the Formula One vehicle, you will find out that the sitting posture of the driver is not upright. It is laid down position, not 100% laid down. You're not going to lay down 100% on your body while driving. It is very comfortable, my God. No, your body is going to be 70% laid down on Formula One vehicle. So just think of this particular scenario. If I ask you to be seated into a particular position like this, where half of your body is in the laid down position, and uh, you are just laid up with the help of your abdomen or with the help of your middle portion of the vertebra, how uncomfortable this particular position is. Many of us cannot remain into this particular position for even 10 to 15 minutes. And think of the drivers who are driving the vehicle for 90 minutes or 2 hours continuously with this particular driving position, with this particular driver ergonomics. Now just think how uncomfortable this particular position is. Moreover, in such a costly vehicle, you will not find out any air conditioner, not even a single air conditioner. There is not even a proper place for the driver to be completely seated. Whenever they sit in, they take the steering out, they get inside, they put the steering back. Such a tight fitment, such a tight fitment, such a tight space for the driver to be seated in. Such a tight space. But please remember this one thing. Formula One vehicle is the specifically designed vehicle. Only purpose is to win the race. If I talk about the Bugatti Veyron, the purpose is not to win the race. Purpose is to develop a vehicle which has got all these standards set apart, bar higher in comparison to any other vehicle present in the world. Not just in terms of its speed, acceleration, stopping distance or anything, but in terms of the overall effectiveness of the product. But if I talk about the Formula One vehicle, the overall effectiveness is not integrated, is not associated with the comfort of the driver, but it is associated with the handling of the vehicle, with associated with who is going to win the championship, who is going to win the race after the drive. Okay, if I talk about the Bugatti Veyron, you will find out that the engine of the Bugatti Veyron, the complete vehicle of the Bugatti Veyron, is going to last longer for years and years and years and years. If I talk about the Formula One vehicle, if I drive this vehicle onto a normal road condition, it is not able to survive those harsh conditions. There are high chances that the engine is going to completely disrupt it after 5 or 6 races. There are chances. If you ever get the chance to look up into top race dragsters, my dear friend, there is the event with the name of top race dragsters. There's the event with the name of top race dragsters. Let's find out the video of top race dragsters on YouTube. You will find out it is just a race of 5 seconds, not more than that, in which they need to cover up a distance of quarter mile, almost 400 meters. Now, 400 meters distance is needed to be covered in 5 seconds, and you are completely on a zero. From zero to this particular distance, from this line escape to this particular line escape in a patch of 400 meters, you just take 5 seconds to cover it. And at the end, you reach the speed greater than or almost greater than 200 kmph. Can you just imagine what is the G acceleration while you achieve this thing, and what actually happens, how these engines are being created? You will find out after the completion of this particular race, which only lasts for 5 seconds. This is the last time. 5 seconds is much a greater time. In this 5 seconds, the engine completely burns. Engine burns down. And not just the engine, their tires also burns down. Tires also. So what is the purpose of developing such vehicles which cannot even last for more than 10 seconds or 20 seconds? Why? To showcase how engineering really works, to showcase how innovation actually works, to showcase how you can improve on design and development of the particular product. Okay, it is about challenging yourself in the domain of engineering. So the purpose of developing a Formula car is completely different. Is completely different in comparison to the passenger cars. Now with this, let me just give you 2 points here. One very important point here. Please write down. Whenever you design any kind of race car, it is always about handling and ride quality. Ride quality. Ride quality is very much associated with the comfort, while handling is associated with the performance. Please remember this one thing. Whenever you go to the marketplace, it's always about handling and ride quality. Handling is about performance, ride quality is about comfort. So what do we actually mean by handling and what do we actually mean by ride quality, my dear friends? So let's just try to understand this thing. So you must have seen these TV ads. In TV ads, whenever we look up, there is a TV ad of Vitara coming up. There's a TV ad of XUV coming up, or any other kind of vehicle coming up into the marketplace. You will find out what do they showcase. They showcase extra leg room. Oh, very good music system. Oh, very comfortable ride. Oh my God. Right. So what they focus on? They focus on comfort of driver. They focus on comfort of passengers. They focus on how you can carry all the equipment that you have got in your home, the extra luggage. Right? This is how they design, this is how they train your mind. If I ask any racer to look up into these videos, they will be finding it completely shitty. Right? Because they're not worried about how comfortable the ride is. If I'm a Formula One driver, I do not want the comfort in the car because I have been trained to design this vehicle for about a decade. For 1 decade, I have been training for this particular day to design a Formula, to drive a Formula car or to drive a race car onto the racing track. Am I right? I do not want the vehicle that is going to be driven by anybody in my family, my grandparents, my father, my mother, my sister, my brother, or anybody in my family would be able to drive this car. No. I just want this car to be driven by me and I will make myself worthy enough to drive it. Yes, that is the handling. Whenever we talk about the race car, please remember this one thing, it is all about the handling. Whenever we talk about the passenger car, it's all about the ride quality or the comfort of the driver, the comfort of the vehicle, the comfort of the passengers. I hope you people are getting this particular point. What do I mean by handling? How the question comes up. Performance could be anything, right? How my AC is working, what is the performance of my car? No. Performance is only mean if my engine is producing certain power, how this power is going to be amplified and will be transmitted to my tires. And it is not just about how much power is being transmitted to my tires, it's about how much power this tire is transmitting with the help of the traction available on the road. And with this, I'm giving you the second point. The first point is handling and ride quality. And my dears, the second point is traction availability. A race car or any kind of performance car is dependent on traction availability. What do I mean by traction availability? Traction means the relationship between the tire and the road. Simple, very simple. Let me just write it down for you. Relationship between, I'm writing it right, T-I-R-E. Some people also write it like this. It is also correct, this is also correct. Tire and road. The healthy relationship between tire and road always assures that your vehicle will remain stable whenever you are going to drive it. The stability of the vehicle, the speed of the vehicle, the acceleration of the vehicle, everything of your vehicle depends on the traction availability. So the first point that I have given you with today's session is the handling and ride quality. When you design a vehicle, please make sure that you will be making a complete matrix. What do you want in a vehicle, handling or ride quality? If you're a student team planning to develop a vehicle with which you will be participating into any kind of student motorsports event, I would request you people to just focus on handling of the vehicle, handling characteristic of the vehicle. You should not have to worry about the ride quality, but just the handling. The second, to assure that your vehicle has got the equivalent handling required to win the championship, you need to focus on traction availability. So even if there is anyone who is focusing on the comfort of the vehicle, they always want the traction to be as greater as possible. Nobody wants to compromise with the traction. And with this, my third point comes up, the most essential point here. Traction depends on weight transfer, weight distribution, and weight transfer. Okay, traction depends on weight distribution and weight transfer. I will be explaining this thing to you people in the later segment of today's session. I hope you people got a bit of understanding of how these things actually work. Okay, so let's not just talk about these things. We are just discussing about the facts associated with the Formula One vehicle. What these facts are, I've just told you about how these things work. Now, second fact, I've just told you about the driver, how the drivers are being seated, or how many forces act on their body. So I just talked about the two facts there. The third fact is associated with the pit stop. So just say if your vehicle is punctured, you are driving a car and your vehicle is punctured. How much time do you think you will take to either repair the puncture, or I would say to replace the complete tire? What do you think? If you are driving a vehicle and suddenly your tire punctures, how much time do you think you would be able to repair? You will take to repair it. Or say for example, if your vehicle got you have got no fuel in the vehicle and you just need to fuel it, how much time do you people take to fuel it back? What do you think, guys? Please write down in the chat box. Please write down in the chat box. How much time will you take to refuel your vehicle? Okay, somebody would be saying it will take at least 1 minute or 2 minutes to refuel the vehicle. Somebody would say that it will take about 10 minutes to 20 minutes to change the tire or maybe to repair the puncture of the tire. Very much possible. But do you know, in a racing event, quite a many times the complete vehicle defuels, like they need to fuel the vehicle again. You need to refuel your vehicle again and again. And how much time do they take to replace all the four wheels, fuel up the complete vehicle more than 50 liters? Oh my god. And if there is any other issue in the vehicle, the entire issue is going to be resolved. And do you think how much time do they take? They take 1 second to 2 seconds just to fuel the complete vehicle up. Fuel up the complete vehicle. To change all the four wheels and to look for all the repairs if required. See, is this not inhuman? Formula One has taught people how the efficiency of the entire process can be achieved. Such kind of efficiency can be achieved. Just think of it. In Formula One races, it's not just about how fast your vehicle is, also about how fast your process of changing the tires and fueling your vehicle is. How fast or how sturdy your entire process of developing the vehicle or repairing the vehicle on the course of track is. Please remember this one particular point, my dear friends. Pit stop. Let's move ahead. Let's move ahead. I won't be talking much about these things now. Let's directly move up with the content now. I've just told you this one thing, that whenever we design the vehicle, we need to focus either on handling or on performance criteria. For any of these things, there are few of the parameters that everyone should have to look up to. Each of us should have to look up to. Okay. So whenever we design a vehicle, let me just do one thing, my dear friends. I need few of the blank pages. So let me get few blank pages for you. Okay. So we were saying, like, if you need to design the complete vehicle, there should be the chronological order that is needed to be followed. So I will be discussing about that particular process now. So before you begin your journey of designing a Formula One vehicle, you need to first look up into the basic systems that are required to design a Formula vehicle. First point. Please remember this one thing, the complete vehicle, even if I talk with a Formula vehicle or any kind of vehicle present in the world, the vehicle design and development is not just a process where you would be focusing on the dedicated entity. Vehicle design approach is not a dedicated entity. It is the integrated entity. Okay, it means there should be no single law, no single formula to define how the vehicle is needed to be designed or how you can calculate all these parameters associated with the vehicle design or development. We say it is the integrated entity, integration of certain systems. The vehicle is not a complete dedicated entity. If I say formula vehicle, if I say go-kart, if I say ATV, it is not a complete dedicated entity. It is the entity developed or designed or manufactured with the help of some integration, with the help of certain systems integration. It means this particular system, if I say formula vehicle is a system itself, the system contains certain subsystems and the integration of these subsystems develops the entire system. So the complete vehicle is the integration of certain systems. Let me just name the fundamental systems here. The first is the steering system. The second is the suspension system. The third is the braking system. The fourth is the transmission system. And the fifth is the chassis frame system. Now, everything else is associated with it. Now, these are the tangible systems that are available in your vehicle. Something that can be touched, something that can be felt, their performance can be felt. There are some intangible systems as well. Now, these intangible systems are also very much associated with the geometry of the vehicle, or is also associated with the traction, with rolling, pitching, yawing, movements are associated with the aerodynamics, yeah, your favorite term, is also associated with the performance enhancing devices like your electronic feedback system, and etc. These are the intangible systems that we generally have in the vehicle. Okay, particularly I want to focus here on aerodynamics, traction, and geometry. Okay, okay, we just got this thing. So your vehicle is the integrated approach. Your vehicle design is the integrated approach, not the dedicated approach. So if you have been given this task to design the vehicle, there should be your vehicle is the integration of certain systems. We first need to define, or we first need to develop the fundamental to start working on it. Okay, so please remember this one thing. If you have been given this target to design a vehicle, you cannot simply just start working on the parameters that are required to design it. First, you need to lay out the foundation, for which I will say the vehicle design is a continuous iteration process. Continuous iteration process. It's a continuous iterative process. Which all starts with a certain fundamental or certain showcase that you people need to develop. So how this showcase is needed to be developed? Let's talk about it now. From the vehicle. First, you need to develop the geometrical model of your vehicle. Or I can also say the kinematic model of the vehicle is needed to be developed. The kinematic model of the vehicle is needed to be developed. Only after developing or designing the kinematic model, you should have to go with the kinetic model of the vehicle. So when I say kinematic model, it means you do not have to worry about what all forces, movements acting on your vehicle. You just need to focus on the mechanism. That if you are developing a vehicle, if you are going to integrate the tires, if you are going to integrate the steering mechanism, if you are going to integrate the suspension system, transmission system, how this thing will behave if no force is acting, if it does not have any weight, then how will my tires corner? How will my vehicle stop? How will my vehicle accelerate? How will my vehicle move forward? You just need to focus on these things without the involvement of any force. Okay, it means the complete geometrical model is needed to be developed. Is needed to be developed without the effect of any inertia acting on it. Once you are done with this thing, then you start focusing on the kinematic model. Sorry, kinetic model. You need to focus on the self weight of individual items, the inertia that it imposes on its own operation. Then you need to focus on the inertia that is being imposed on this particular system by some other system, because it is the integrated system. The effect of steering on suspension, the effect of braking on suspension, the effect of transmission on suspension, the effect of chassis frame on suspension. Okay, and vice versa in the other ways around. You need to focus on that particular thing as well. So let us try to understand how this particular geometrical model is needed to be developed. I've already given you 3 points: that everything depends on the ride quality versus handling. Second, everything depends on the traction. Okay, and third, everything depends on the weight distribution and weight transfer. So we will be looking up into those things as well. For that, I'm just developing a base. So engineeringly, whenever you will be designing your vehicle, let's look up to your vehicle from three views. We just know about the 3D view, and in 3D view, we can say that my vehicle has got three views. I can see it from the front, I can see it from the right, from side, like from right to left, or I can see it from top or bottom. Okay, so there are going to be three views: the front view, side view, and top view. So in all these three views, you need to develop different geometries to define every performance criteria of the vehicle. Different geometries are needed to be developed to define all the possible configuration setup or the performance criteria of the vehicle. Okay, got this thing. Let's move ahead. Let's move ahead. So if I say my vehicles look something like this: four wheels, two on front, two on rear. Which view is this? Which view is this? Write down in the chat box. Write down in the chat box. Which view is this? You would be saying this is the top view of the vehicle. From the top view, this is how my car looks like. My dear friends, if this is the top view, now I'm going to give you certain engineering terms. Now we have started up with the dynamics of today's session. If I say, if there is the infinite axis that is passing from front to rear or vice versa, the infinite axis passing from front to rear of my vehicle, this particular axis from the top view, I'm looking up at my vehicle from the top view, this particular axis is regarded as the longitudinal axis. Is regarded as the longitudinal axis. The axis that passes from right to left or left to right, right to left or left to right, okay? This particular axis, my dear friends, is considered as the lateral axis. I want you people to please respond me on the chat box. If you people are here listening to me, I want you people to please respond me on chat box. Write down anything, literally anything. Just say everything is going good or whatever you want to say. Just please write down something in the chat box so that I could get to know that you people are aware, you people are listening to me. Okay. The axis that is passing from right to left or left to right is regarded as the lateral axis. And that axis that passes from top to down or down to top is regarded as the vertical axis, VER, vertical axis, or you can say transverse axis. Okay, transverse axis. Now please remember this one particular thing: your entire engineering, motorsports engineering, is dependent on these terms. Front to rear, rear to front is regarded as the longitudinal axis. The axis passes from right to left or left to right is regarded as the lateral axis. The axis that passes from top to down is regarded as the transverse axis. That's it. Now when my vehicle is moving, forward, you will find out there are certain movements that are acting on it. Now just see, if my vehicle is moving straight, now see, the movement that is occurring along this longitudinal axis, now this is the longitudinal axis, front to rear. This is the lateral axis, sideways. This is the lateral axis, okay, and this is the top down axis or the vertical axis. Now my dear friends, in any of these conditions, you will find out if my vehicle is moving forward like this, and there is any movement like this, see, slightly movement like this, right to left, left to right, right to left, left to right, this particular movement is occurring along the longitudinal axis. This particular movement is occurring along the longitudinal axis, and we call it the roll movement. We call it the rolling movement. Okay, so if I'm moving my vehicle onto the racing track, and because of the surface irregularities, right to left to right, the movement that is occurring in my vehicle is regarded as the rolling movement. Great. And now I'm moving my vehicle at a very fast speed, at a very high speed, and suddenly I apply the brake. What happens? Or I just accelerate my vehicle. You can just see. Whenever I accelerate my vehicle, what actually happens in the next video? See the same vehicle moves upward or downward. I apply the brake, the weight transfers from the rear axle to the front axle. Oh my god. The weight transfers from the rear axle to the front axle. Whenever I apply the brake, the weight transfers from the rear axle to the front axle. During braking, the weight transfers from the rear axle to front axle. During acceleration, the weight transfers from front axle to rear axle. Now this movement is occurring along the lateral axis, and we call it the pitching movement. My dear friends. Okay. Now, when I am moving my vehicle at a certain speed and I thought of taking a corner, and I took a corner like this. I took a corner. So when I took a corner, what kind of movement is this, my dear friends? What kind of movement is this? You will be saying this particular movement is occurring along the vertical axis or the transverse axis, and we call it the yaw movement. Okay, so I'm moving my vehicle onto the racing track. Have I provided anything so that the rolling movement occurs? No, I'm just moving it. I'm moving my vehicle forward. But because of surface irregularities, the weight is transferring from right side to left side or left side to right side. The weight transfer is taking place. That's why I'm moving right to left, left to right. Okay, and we call it the rolling movement. It means I have not provided the input for rolling movement. No input provided for this particular movement. Okay, now I'm just accelerating my vehicle, and as I accelerated, the weight transfer from the front axle to the rear axle. I just move backward, or I just applied the brake and I'm moving from back to front. Have I provided any movement for it? No. It means this pitching movement, I have not provided any input. No input provided. Okay. Now I'm moving my vehicle forward, and suddenly I found out that I need to take the right side corner, or maybe I want to move towards the left side. To do so, I am providing the input, and my vehicle is turning, my vehicle is cornering. It means I have provided the input. Input provided. Now write down the fourth rule here. Vehicle is all about the reaction to response mechanism. Vehicle design and the vehicle designing process is all about the reaction to response mechanism. This is the fourth point that you people need to remember. Reaction to response mechanism. What do I mean by reaction to response mechanism? So I am moving my vehicle forward. I thought this is the time for me to start accelerating. So I accelerated my vehicle. Okay. What response have I provided? I provided the response of acceleration. How did my vehicle reacted? My vehicle reacted by moving forward and making me move backward. Okay. The response of the driver to a certain reaction of the vehicle, or the response of the vehicle to certain reaction of the driver. So I'm moving suddenly I'm driving my vehicle at a speed of 100 km constantly. Okay, and suddenly I found out there is a person standing right in front of me, and as soon as I looked up to this particular scenario, I reacted to the situation. And how I reacted? I reacted by applying the brake. I applied the brake. Now I reacted to this particular situation by applying the brake. And as soon as I reacted to the situation, how did my vehicle respond? My vehicle responded by stopping to a certain distance at a certain limit, and at the same time making the driver go back. Okay, sorry, making the driver to go in the frontal windshield area. Got my point? It's all about the reaction to response mechanism of the vehicle and the driver. Vehicle and the driver. So the fourth point is reaction to response mechanism between driver and machine, that is your vehicle, race car. Okay, now out of all these movements, my dear friends, I have just told you that only yaw is the desirable movement. Yaw movement is the only desirable movement, while roll and pitch are the derived results of some other action. I just want to move my vehicle forward because surface irregularity rolling is occurring. I just want to accelerate my vehicle because of acceleration, the weight transfer from the front to rear, or I just applied the brakes in my vehicle, the weight transfer from the rear to the front. So these are the derived forms of some other action. But yaw is the direct result of my action. So the only desirable movement in my vehicle out of these three movements is the yaw movement, that is acting along the transverse position. That is acting along the transverse axis. I hope this particular point is clear to each one of you. Okay. Now it means that rolling and pitching imposes certain challenges to the vehicle. Challenges to the vehicle performance, as well as when you are smart designing a vehicle, you can also convert these challenges into your benefit. So look up, this is a car, this is the longitudinal axis, this is the lateral axis, and this is the transverse or the vertical axis. The movement along the longitudinal axis is regarded as the rolling movement. The movement along the vertical axis is regarded as the yaw movement. And the movement along the lateral axis is regarded as the pitch movement. And where does all these axes pass from? These axis passes from the center of gravity location. Please remember, this axis passes from center of gravity location. Okay, so I've designed the complete vehicle. I have just thought of designing the vehicle, and now I'm going to formulate everything on a piece of paper. And to formulate it, my dear friends, there are certain rules and regulations that are needed to be understood. First, if this is my vehicle, and now my vehicle is moving forward. Okay, and now I thought of changing the direction. So now, my dear friends, there is one thing. Projected, I am changing the direction like this. Okay, changing the direction. Now it is curved. The projected direction, or let me just make a curved vehicle. Earlier this vehicle was moving straight, but now it is turning. So I can say the projected path of my vehicle is this. Okay, like this. See here. Passing from the center of the rear axle and the front axle. This is the projected path of my vehicle. Very good. Please remember this one thing. This is the projected path of vehicle on track. But in actual, you will be looking up, you will find out your vehicle is taking the corner, something like this. So this is the projected path. Let me just use different colors to give you the better understanding. This is the projected path. And this one is the instantaneous path. Someone who is standing there on the front can see the vehicle is moving here, not here. On the long term, I can see the vehicle is moving here, but in actual, I can see the vehicle is moving into this particular direction. So now see here into this particular photo. This is the path, the vehicle path, original path. This is my projected velocity from the rear center to the front axle center. And in actual, I am not moving into this particular direction. I am moving either here or I am moving either there. So my dear friends, you will find out there is a difference. Between the projected path and the instantaneous path. So from the From the vertical, if I say there is the angle psi that is being made with the projected path, I can call this to be the heading angle. Angle of projected path. Okay, and the real angle is nu from vertical. See, from this particular longitudinal axis, the real angle is nu, and the difference between psi and nu is considered as the slip angle. My dear friends. In your entire vehicle design, the biggest failure, the biggest issue that you will be finding out, losses that you will be finding out, are very much dependent on slip. So this term is going to come again and again when you start your journey in the field of formula design. This is regarded as the slip angle. So just think of this particular scenario. If your vehicle is moving forward, you are not providing any steering input. It means that you are moving on a straight line, but after a certain time you will find out that actual course, say for example after 1 kilometer, 2 kilometers, or maybe after 1 meter, 100 meter, 20 meters, you will find out that your path is deviating by 0.1 degree, okay, or by 0.01 degree or 0.5 degree. In actual, you plan to move straight, but your vehicle is moving straight, but after every 1 kilometer you find out that your vehicle is slipping 1 inches. Your vehicle is slipping 1 inch in the left side, or is slipping 1 inch in the right side. Why is this thing happening? And this change in course of the vehicle, the lateral course of the vehicle, the change in lateral course of the vehicle, my dear friends, is regarded as the slipping. There could be any reason associated with the slipping in a vehicle. There are many reasons. Say for example, I am moving straight, but the road is gradient. There is a gradient in the road. Okay, or I can say one of the tire here is punctured. You must have noticed when one of the tires is punctured, is having the lesser air pressure, the vehicle shifts onto that particular direction. It starts moving. It becomes hard for you to stay in the opposite direction, right? It becomes difficult for you. So your vehicle is actually moving into this particular direction. There could be the change in the alignment of your wheels. The right and the left tire are not aligned equivalently along the longitudinal direction. Maybe on right side the weight is more, the left side the weight is less. There could be n number of reasons. There could be n number of reasons that lead to the slip of the vehicle. Leading to the slip of the vehicle. Remember this one thing: the biggest reason that is associated with the slip of the vehicle is the traction availability on the vehicle along the longitudinal directions. Okay, traction availability on the wheels along the longitudinal direction. So if this is the vehicle, the wheels along the longitudinal direction are this set and this set. Okay, the traction available on this set of tires is different from the traction available on this set of tire. If it is the condition, no matter what you do in life, no matter how good engineer you are, you will not be able to eradicate the 100% slip out of it. You can manage it. You can manage it, but you cannot eradicate it. You can manage it, and at the end you will be coming up with the average 0 value, but you cannot eradicate it completely, my dear friends. Please remember this one particular point here. Okay, having said this thing, let's move forward. Everything in this vehicle is dependent on two factors. The first factor is weight distribution, and second factor is weight transfer. The first factor is weight distribution, and second factor is weight transfer. Just give me a moment, guys, so that I can add on more slides for you. Okay. Let's move ahead. So everything in your vehicle's dynamics depends, the vehicle's behavior, the vehicle's performance criteria depend on two factors. The primary factor is the traction, which further depends on two factors: weight distribution, and second is weight transfer. Weight transfer. Your vehicle's performance and everything depends on these two factors. Primarily, it depends on traction. Okay, so let's understand how does weight transfer and weight distribution and weight transfer assist you developing or designing the effective vehicle. So say for example, I just went to the marketplace and I purchased the vehicle. This is how my vehicle looks like. Okay, this is how my vehicle looks like. My vehicle is moving forward into this particular direction, and now see, this is my tire. These are my tires. In the entire vehicle, the only reactional surfaces that you will find out are your tires. Tires are the only reactional surfaces. Okay, if I say what is the total weight of the vehicle, I would be saying the total weight of the vehicle is W. Where have I marked it? At the location of center of gravity, but I do not know where is my center of gravity. Oh, that's a big challenge. I need to first find out where is my center of gravity located. Where is my center of gravity located? Where is my center of gravity located? Now this is the side view, my dear friends. In the side view, the measurable quantifications are this particular distance and this particular distance. Okay, this particular distance and this particular distance. It means the height of center of gravity and the center of gravity distance from the front tire center contact patch and the rear tire center contact patch. From the front tire center contact is B, from the rear tire center contact patch C. Now, if the rolling reaction surfaces are these tires, and I look up at my vehicle from the side view, I can say the right side tire and left side tire condense together for the front and for the rear. So I can also the total weight, if I want to calculate the total weight of the vehicle, how can I calculate it? I will be putting up two weighing machines, one on the front axle and one beneath the rear axle. So the total reading that I will be finding out on the total reading I will be finding out on the front tire is WF and on the rear is WR. So I can say the total weight of the vehicle W is equals to the weight that I have seen on my weighing machines, that is WR and WF. My dear friends, let me be very clear here. This is not going to be WR or WF. This is going to be NR and NF. Okay, NR or NF. Let me make it NR and NF. Okay, NR, the reactional force. Okay, the normal force. The normal force. The total weight of the vehicle on the rear tire here. I do not know how much it is. So let's say on the rear tire it is WR. On the front tire it is WF. But there are high chances that there is certain suspension system, there is a kind of system that is going to damp the weight over the surface. There is a kind of, in the entire dynamic mechanism, there is something that is dynamically changing the weight. So if I consider that any effect of such mechanism is not considered, then I can say that NR and WR, that see the tire is touching the ground, it means NR and WR are equal. Similarly, NF and WF are equal. So I can also say that W is equals to WF plus WR. WF plus WR. Got this thing. Let me just redraw this particular diagram for you people to have the better understanding of what I am about to discuss. It is a bit different in comparison to the previous vehicle that I have designed. Now see, the total weight is W. The weight of the rear tire is NR. The weight of the front tire is NF equal to WF equal to WR. Okay. The distance of the center of gravity location from the rear axle is C. The distance of center of gravity location from the frontal tire center contact patch is B. The height of center of gravity from the ground is H. We have just discussed that W is equals to NF plus NR is equals to WR plus WF. Also WF plus WR. Okay. Everything is similar. I have just earlier written NF plus NR. That's why I have written WF plus WR rather than writing WR plus WF. Now, having said this thing, let's move forward. If I talk about the weight distribution, how much weight is on front and how much weight is on rear? If you were just putting up the weighing machine, you can easily calculate it. But mathematically, how do you find out this particular thing? So if I say the vehicle is in equilibrium condition, So the rear tire, if I say this at this particular position, the vehicle is at equilibrium. So let's calculate the moment here. The vehicle is completely at equilibrium. Let's calculate the moment here. So if I say that the anti-clockwise is positive and clockwise is negative, so I can say, okay, NF or the WF along this point. Let's calculate the moment along this point A. Calculate the moment along this point A. So I can say WF into this distance B plus C. B, C. Anti-clockwise positive, okay, and C minus W into this distance C. Vehicle is not moving, it's stationary, is equal to 0. I can say WF is equal to W into C by B plus C. If I put up this value here into this equation, you will find out that WR will become W into B by B plus C. Okay, B plus C. What is B plus C? Please remember this one thing. B plus C is the distance of the tire's center contact patch with the ground, front tire center contact patch with ground to the rear tire center contact patch with the ground. My dear friends, please listen to my words very carefully. I am saying tire center contact patch. Now see, this is the tire. Oops, I make very bad drawings. Erase this. Make a line. Okay. Now see, here you can see the center of the tire and the contact patch. See, the tire is making this contact with the ground. The center of the contact and the center of the tire are absolutely similar. Very good. And if I say what is this distance? Make it like this. The center contact patch to center contact patch. This is the center of gravity location. This distance here, the axis, the vertical axis passing through the center contact patch. The vertical axis passing through the center contact patch. The vertical axis passing through center contact patch and center contact patch in the static condition. This is B, this is C. This distance is also considered as the wheelbase, is equal to B plus C. I can also write it like L. Wheelbase. Okay, wheelbase. Now think of the scenario in a way. Oh, now see. Okay, and the other tire here, or just leave it. Make the other tire on ground. Now in such scenario, you can see the tire center is heading here. Okay, but the center contact patch is here. Okay, center contact patch is here and the tire center is here. The tire center is here. What is the wheelbase? You won't be saying this is the wheelbase. No, the wheelbase will be this distance to this distance. Tire center contact patch center to contact patch center. It means dynamically wheelbase also changes. So when you design the complete vehicle, you decide what all kind of suspension systems you will be using, what all kind of what tire size you will be using in your vehicle. It depends on this particular factor. How much your tire will change, your wheelbase can change in any dynamic condition, considering the kind of bumps or droops your vehicle will be encountering. Okay, so I've just told you about the weight distribution. My dear friends, what if your vehicle starts moving? Let me just remove this. Now see, I'm going to make the same diagram again. Okay, now see, if my vehicle starts moving at an acceleration AX, now see, the total weight of the vehicle is W. Here, the rear is NR is equal to WR. The front is and F is equal to W. I'm still not considering the effect of suspension or anything else to make it complicated. This is just the fundamentals, so I will be just telling you about how these things are needed to be notified together. The center contact patch to center contact patch distance here is B, is A, this height is H. But now my vehicle is moving forward at an acceleration AX. So I can say the force that is acting on the body as per the D'Alembert law will act in the opposite direction. That's why when we are seated inside the vehicle, you must have noticed this thing, that when you're moving forward, everything looks like it is moving backward. The trees, the other traffic looks like they are moving backward. It means we always consider the reactional forces. See, we know this thing, the force is acting downward, but what we have considered, it is acting upward. The force is reactional in nature. It's not the action, force is the reaction. So even if you're moving forward, we say the force is acting in the backward direction. How much force? MAX. Or I can also write W is equals to mg. So I can say M is equals to W by G. Hence I can also write it like W by G into AX. This is the force, accelerated force acting on your vehicle. Now, if your vehicle is moving forward and I say that your vehicle is having the equivalent condition, equilibrium condition, if a vehicle is moving forward with the equilibrium condition, then how will you justify this? How will you find out what is the weight transfer, what is the weight distribution now? So as I accelerate my vehicle or decelerate my vehicle, I find out the weight transfer occurs. Now earlier in the static condition, the weight is F is equals to W into C by L. B plus C is equals to L, or W into B by L for the rear tire. Or I can also write this particular equation in a way that in a static condition, WFS, static condition, is equal to W into C by L. WR static is equal to W into B by L. Putting up in a box. Putting it into a box. Let's move forward. Okay. But when as soon as I started to accelerate my vehicle, what will happen? Now see, let's take a moment along the rear tire center, call it A, center contact patch. Let's say the anti-clockwise direction is positive. Okay. The moment along point A from WF is equals to WF into B plus C. Okay. Minus W into C. Okay. Now see, your vehicle is moving forward. This is the direction of the force. Again the anti-clockwise. Plus W by G into AX into, this is the longitudinal force, into H is equal to 0. Now you will find out in this scenario, WF will become W into C by B plus C minus W by G into AX into H by B plus C. Or I can also write W into C by L minus W by G AX into H by L. W into C by L minus W by G into X into H by L. Similarly, WR will become W into B by L plus W by G into AX into H by L. Now, even in this scenario, we know this thing that W is equals to WR plus WF. And I have just showcased you that WRS is equals to W into B by L. WFS, static condition, is equals to W into C by L. Now, when you accelerate a vehicle, I have told you that WR will become W into B by L, accelerate your vehicle, plus W by G into AX into H by L. And WF will become W into C by L minus W by G into AX into H by L. My dear friends, when you look up into this particular equation keenly, you will find out that WR is equal to, see, what is this? Static weight plus this value. WF will become static value, WFS minus this value. If I say this value, W by G into AX into H by L is equal to WT, I can write it like this. What is WT? This is the weight transfer. So whenever you accelerate a vehicle, you must have noticed the weight transfer from the front axle to the rear axle. But by what count? This is the count. This is the value by which the weight transfer takes place. And the weight transfer depends on what? W by G into AX into H by L. It depends on H by L ratio. What is H? Center of gravity, height. L is wheelbase. So you must have noticed this thing, all the racing cars, the top speed cars, the wheelbase is bit higher. They are very long. Why? Because that whenever you accelerate the vehicle, the weight transfer should have to reduce. Because if the weight transfer occurs, what will happen? The traction will disturb. The traction will disturb. The traction will disturb. The relationship between the tire and the road will disturb. And you do not want this thing to happen. Right? So in any condition, so in any condition, we know this thing that H by L ratio should have to be minimized. That's why all the Formula One cars, their ground clearance is very less. The ground clearance is very less. Why? And why they ask the driver to be completely laid down rather than asking the driver to be seated like this in the upright position, be very comfortable. Why? Because the driver is going to be seated, center of gravity height will also increase. They do not want the height of center of gravity to increase. Okay, that's why they do this thing, my dear friends. I hope you people are getting this particular concept. That's why they do this thing. That's why they ask the driver to be completely laid down while driving the vehicle at such a high speed. So I hope this particular thing is clear to each one of you. Okay. Now, my dear friends, and each one of you also know this thing that this particular session is all about the free certification session. So you all will be rewarded the certificate of participation for attending today's session. I have shared one link in the chat box. I request each one of you to please mark your attendance into that particular sheet. I want each one of you to please mark your attendance. If you are attending this session, if you are with me here listening to me, I want you people to please mark your attendance in the Google form that I have shared with you. Those who will be able to mark their attendance successfully will be awarded with the certificate of participation into today's session. Please remember this one thing, only the students, only the participants who would be able to fill this attendance sheet in the next 5 minutes will be getting the certificate of participation. In the next 5 minutes, please listen to me very carefully. If you would be able to fill this attendance sheet in the next 5 minutes, you would be getting the certificate of participation. Please mark your attendance now, everyone. Please mark your attendance. In the meanwhile, if you have not subscribed us, I would request you people to please give us a subscribe on our YouTube channel. We will be coming up with many more workshops in future, giving you the understanding about everything that is associated with motorsports engineering. We will also be coming up with the short videos with the complete course on motorsports engineering, automobile engineering, and mechanical engineering. Please subscribe this YouTube channel. Fill this attendance sheet in the coming 5 minutes to get the certificate of participation into today's session. You have got only 4 minutes left to fill this attendance sheet. Please do it fast. Please do it fast, everyone. Please mark your attendance. Only the students who would be able to mark their attendance or would be able to fill this attendance sheet, they fill this Google form, in the coming 3 minutes would be awarded with a certificate of participation for today's session. If you like today's content, if you're liking the content that we are discussing as of now, I want you people to please write down or please make the hearts in the chat box. Please make the hearts in the chat box. Please mark your attendance. Do mark your attendance now, everyone. I have got the response of 19 learners up till now. There are many more who are yet to fill the attendance sheet. Please do it. If you have not followed us on Instagram, I would request you people to please give us a follow on Instagram as well. Simply go to Instagram, search for ARC Global, or you can write down our username there, underscore ARC Global. Give us a follow there. You will be getting all the updates regarding our coming workshops on Instagram. Please give us a follow on Instagram as well. Okay, the attendance sheet has been filled by 22 members now. Everyone else, please fill the attendance sheet. I've already shared the link of the attendance sheet, the Google form with you people in the chat box. Do it now, do it now, do it fast. I've shared it again for one last time, the Google form. I want you people to please fill it. If you're liking the content, go for the thumbs up in the chat box or drop the hearts in the chat box so that I can get to know that you are enjoying the content. Everyone, please do it now. Be quick. Okay. It's okay. So if you fill the attendance sheet, it's absolutely fine. It is going to remain open for next 1 minute, and I will be then stopping. I will be stopped taking up all the responses on the attendance sheet. Okay. So without wasting much of your time, let's continue with the content. I just told you people how the weight transfer takes place, how weight distribution is necessitated in your vehicle. I hope it is clear to you people. So even when you apply the brakes, all you need to do is to change the direction and everything will change. Okay, the symbols will change. The plus will become negative, the negative will become plus. And you will find out whenever you apply the brake, the weight transfer of the rear axle to the front axle. How will you quantify it? This is the value of weight transfer that you will be finding out in your vehicle. With the help of suspension system, this weight transfer can also be changed. Now, if you people are developing a Formula car, you want to have the quick vehicle. You will be having a quicker vehicle. A vehicle that can accelerate as quick as possible and would be able to decelerate as quick as possible. So it's not just about acceleration, it's also about deceleration. You should be able to stop your vehicle, you should be able to decelerate your vehicle at the high speed corners and quickly accelerate it after covering that particular distance out. Okay, I hope it is clear to each one of you. So to have the high speed acceleration, to have the high speed deceleration, you also want to make sure that the weight transfer should have to be as less as possible. Now, if you people are the bike riders, how many of you drive bikes? Could you please tell me in the chat box? Please write down that you ride bikes or whatsoever bike you people ride. Please write down the name of your bike in the chat box. Apache, Pulsar, Discover, KTM, Bullet, whatever the bike that you people ride, please write down in the chat box. Okay, now you must have noticed this thing that people used to come do certain stunts with their bikes, and we call it like few common stunts are quickie and wheelie. Sorry, not quickie. I'm really sorry. Wheelie and stoppie. I'm not sure if I've written the right spelling of these two things. I'm really sorry. I don't know the spelling of wheelie and stoppie. But you must have seen this thing that you are riding a bike at a very high speed and you apply the brake. The rear tire rises up. We call it a stoppie, right? You are moving a vehicle like you are just at a stationary position. Suddenly you accelerate your vehicle, the front tire rises up. We call it wheelie. How does wheelie occur? And how does a stoppie occur? Now see, I am moving my vehicle at a certain speed. La la la, la la. I am moving my vehicle at a certain speed. Moving at a certain speed. This is front NF. This is rear NR. I call NF to be the WF and NR to be the WR. Okay. The total weight of the vehicle is W. Okay. If I would be able to move my vehicle forward, my engine does not know anything, but it only knows that this is my output shaft, and my output shaft would be able to rotate at a certain speed, at a certain RPM. My engine does not know what I'm going to do with it. My engine only knows this thing that if you provide me the fuel, if you burn the fuel inside my combustion chamber, then this is the output shaft which will be rotating at a certain RPM. And even if you put up certain load on it, so this is my shaft, output shaft, output shaft is rotating at 10,000 rpm. Engine is saying if you put up a load of 1 kg on it, then also it will be rotating at 10,000 rpm. If you put up a load of 10 kg, then also it will rotate at a 10,000 rpm. If you put up a load of 20 kg, then also it will be rotating at the 10,000 rpm. Okay. If you put up a load of 50 kg, then this rpm will reduce to say 9,000 or say 5,000. Okay, this is how things usually work in the complete vehicle. This is how things usually work in the vehicle. Okay, so I won't be getting into the details of this particular thing. If you want to know about the details of this particular thing, last week on Tuesday, we got a session where we discussed about how this entire engine dynamics work, how fuel burns, what power, what torque, what RPM it generates, and how it generates those things. We have discussed about this thing in detail in the last session. So you can just look up into the Baha Buggy Design and Dynamics by University Global. Simply search it on our YouTube channel. You will be getting the complete detail there. Okay, having said this thing, let's move forward with the discussion. My engine only knows this thing. So if the engine is connected, engine output is connected with the tire, the only thing it knows that the tire should have to rotate. But in actual, your tire is not just rotating, it is also making sure that your vehicle is moving forward. Your vehicle is moving forward, your vehicle is moving rearward, your vehicle is moving right or left. It is changing directions. And if this thing is happening, we are developing the relationship between the tire and the road. We are developing a relationship between the tire and the road, and this relationship is known as the traction. We call it the traction. And the entire traction is dependent on how much load your tire is carrying. Okay, if you want your vehicle to have a certain acceleration, you need to check what traction is available. Do you have the enough traction to achieve this acceleration or not? If you say I want this speed, then you will be just checking, do you have enough traction to achieve this particular speed or not? Or if you say that my vehicle is moving at a speed of 300 km per hour and I just need to stop this vehicle within 5 seconds, then you will be checking, does your tire have enough traction to make you achieve this particular deceleration rate or not? Everything depends on traction. Okay, everything depends on traction. So what is traction in actual? You will be finding out the traction of the rear tire here is mu into nr. The traction of the front tire is mu into nf. If it is a rear wheel driven vehicle, it is limited to the mu nr. If it is a front wheel driven, it is limited to the mu nf. So this is the traction. So as you increase the weight on the rear tire, what will happen? The traction will increase. Okay, this is something completely opposite. People say that you need to design the vehicle as light as possible, but I am saying when you increase the weight, the traction will increase. Yes, I am right. Say for example, your engine is producing a certain power and it says that my engine would be able to achieve 10,000 rpm, my output shaft. And even if you provide 100 Newton meter of load, see it's the engine rotating part. So for the rotating part, I won't be saying the kilogram weight or the Newton weight, I will be saying Newton meter of weight, rotational weight. So even if I say if you provide 100 Newton meter of load on my shaft, then also it will be able to achieve 10,000 rpm. I assure the same thing. I assure the same thing. The same load is needed to be applied to my tires to assure that the vehicle remains stable during cornering or during high speed acceleration or deceleration. Okay, please remember this one thing. Your traction should have to be as high as possible during braking, during acceleration, and during cornering. Okay. Okay, so what is keeping your tire on road? This mu nf or this mu nr is keeping your tire on road. Okay, so I have just said that the total weight on the front tire is wf and nf is the reaction. Nf is the reaction. Nr is the reaction. Wr is the load that is acting on it. Okay, my dear friends. Now please understand this thing. This particular force is trying to move your tire upward. Okay, move your tire upward. So when I say that during acceleration or during deceleration, the weight transferred, say for example, during deceleration, the weight transferred from the rear tire to front tire, mu into Okay, and the front tire, the weight increase, W into C by L plus W by G into AX into H by L. Now this is the weight transfer. Okay, WR. The traction here is mu into WR. But what if I say the weight transfer value W by G into AX into H by L is greater than W into B by L? The static weight on on the rear tire is WRS. If the weight transfer value is greater than the static weight, then what will happen, my dear friends? The tire will rise up. The tire will rise up. So how is it possible that W into B by L is less than W by G into AX into H by L? In what condition can that happen? When the acceleration or the deceleration is very high, or H by L ratio is very high. Now in the bikes, you must have noticed this thing, that you are having a very high center of gravity height. In the case of Formula 1 cars, whenever they accelerate and whenever they decelerate, the tire not rises up. Whenever you take a corner, the centrifugal force is acting from one side to other side. That can also topple your vehicle sideways. That can also roll your vehicle sideways. In Formula 1 cars, you must have noticed this thing in the highways. It's written the top speed for a car is 100 kmph. The top speed for the truck is 60 kmph. Why do they have lesser top speed for the trucks? Why? Because they know that the height of center of gravity of the truck is much higher. So if the truck is going to take the high speed corner, then there are high chances that because of the elongated, extended center of gravity height, the truck can topple down sideways. It's not just about toppling. The W by G into AX into H by L minus W by G into C by L or B by L. Okay, C by L in the case of braking, or say B by L in the case of acceleration. B by L in the case of acceleration. Front tire. What will happen? The traction will reduce. What is the traction? Mu into WF. The traction will reduce. It means the tire will not maintain its proper contact with the ground. So in such scenarios, you must have noticed this thing, at very high speed, your steering becomes very light. And sometimes you just need to corner it. Either it corners more, either it corners less. It does not get in your control. Okay, so this is how the weight transfer plays its role in the vehicle design. So please remember this one thing, that whenever you are designing a Formula vehicle, you need to make sure that your traction availability should have to be as high as possible in any possible scenario. In any possible scenario, your traction availability should have to be as high as possible. Okay. So this is how traction plays its role. If any of you want to learn about the Formula vehicle design, ATV design, go-kart design in detail, I would recommend you people to join any of our internship come training program. These are 30 days elongated program where we discuss the complete details of individual items. Okay, so if you're participating in the CAE, you will become the master of CAE in 30 days. Every day we will be having the 1 hour of session. All the participants will be getting 3 different certificates from industry. The certificate of your training, the certificate of the project that you will be doing along with it, and the certificate of internship from our industrial partner. If you join this automobile program, you would be able to design any kind of vehicle. If you join the EV vehicles, you will become the master of EV design in 30 days. And please make sure that this particular activity is not going to be the individual activity. You will be working with a team. It means if there is a batch of 20 members, you will be developing a team along with those members and developing the complete vehicle. You will not just able to learn how to design it, but you will also be able to practice it along with the team that we will be forming along with you. So I would request each one of you to please visit our website achillesracingclub.com/internships and find out the details about these programs. These programs comes up at a very minimal cost of only 3,500 for 1 month, where you will also get the assistance of 6 months into the project development. Okay, if you want to know more about this particular program, give us a WhatsApp message on 8800219630, or you can simply find us on Instagram and drop us a message on Instagram DM. Okay, you can also think of following us on Instagram. We have more than 1,000 followers on Instagram. We are available on Instagram with the name of ARC Global. Underscore ARC Global is our username. Please find us on Instagram. Let's move up with the content. Let's move with the content now. So everything in your vehicle depends on the traction availability. So if your vehicle is taking a corner, the centrifugal force will act on your vehicle, and this centrifugal force will assure that your vehicle will topple down. Formula One vehicle is all about the high-speed cornering. Is all about the high-speed cornering. And to make sure that your vehicle can corner at a very high speed, you need to make sure that the traction availability always remains high. Traction availability always remains high. So even when you look up into the Formula vehicles, or when you are going to design a Formula vehicle for yourself, you will be selecting the tire in a way that the contact patch of the tire always remains greater. So the Formula One tires are unusually wider in comparison to the normal passenger car tires. So how do you increase the traction? You increase the traction by increasing the contact patch of your tire with the ground. Okay, how does it maintain this particular relation? So see, no surface is 100% smooth. There are certain frictions available between the tire and the road. So see, at the micro level, this is how your road looks like, the smoother ground road looks like. And this is my tire made up of rubber compound. So rubber has got certain elastic properties, and the elasticity of rubber is much lesser in comparison to other kind of items. So what will happen as the rubber gets onto the surface, this tire gets onto the surface, this rubber will try filling up with this particular space, this particular micro space. Hence, increasing the effective contact patch of the tire with the ground. And as soon as I provide certain thrust on my tire, see what happens, the tire will start moving forward. The tire will start moving forward. So see, the tire and the road are connected with the help of adhesive force. Adhesive force is the kind of force that exists between two different materials. And within the tire, if you look up into the layers of the tire, you will find that the rubber compound is connected together with the help of cohesive forces. Now as the load is acting on it, this rubber will compress, and when it compresses, it will get inside the road profile. Now see, this is the tire, this is the road profile at the micro level, and this is your tires profile. Filling up all this gap. Okay, hence maintaining the high value of traction. You must have noticed this thing, the vehicle having the lesser tire pressure, not very less, but the lesser tire pressure imposes better stability in comparison to one with the lesser tire pressure. Okay, lesser tire pressure. So you must have noticed this is how it is getting inside it and maintaining the effective contact patch with the ground. So as soon as you accelerate your vehicle, the temperature of the tire, because it is having the friction with the ground surface, the temperature of the tire increases. When the temperature of the tire increases, the gases inflate inside the tire. When the gases inflate, the tire becomes stiff. When it becomes stiff, what happens? Earlier it was having this particular C. It has filled up all the gaps at the micro level, but now what is happening? It is moving upward. This is the micro level properties of the tire, and this is how my road is. The micro level behavior of the road will not change. Now you can see the contact patch distance here and here is different. The contact patch is different in both the scenarios. If the contact patch is reduced, my dear friends, at the high speed, what will happen? The stability will also reduce. So whenever the weight transfer occurs, the weight from the rear tires goes to the front tire, what happens? The contact patch of the rear tire also reduces. Whenever you accelerate your vehicle, the weight transfers from the front tire to the rear tire. It means the contact patch on the rear tire, front tire reduces because the weight is transferring from the front to rear. getting reduced on the front tire, because of which the traction on the front tire reduces, but the traction on the rear tire increases. Now, when you are going to corner your vehicle, you will be using your steering. So see, the contact patch on the front tire is less. It means the reaction is less. So whenever I will be using the steering system, how will I use it? I want my tire to move from this longitudinal position, from this position to this particular position, for which the tire should have to make a frictional contact with the ground. The frictional force will act on it. But if the total weight on the tire will reduce, the frictional force is the lateral mu into the weight on the front tire, this particular value is less in comparison to the external forces that is acting on the tire. Hence, it will not allow you to turn your wheel. It will not allow you to turn your wheel. Okay, effectively, you cannot control the direction. You cannot control the direction. At high speeds, you just provide this thing, vehicle moves here and there, it becomes difficult to control, right? The vehicle actually oversteers in such situations. In the case of acceleration, a vehicle oversteers, you cannot control it. You want to steer the vehicle by 5 degrees, it is steered by 10 degrees or 20 degrees. Please remember this thing, how it actually works. Okay, so with this, I have given you the basic glimpse that whenever you are required to design a Formula One vehicle, what all rules you people need to remember. So I just told you one thing, the most important rule is the traction. And when it comes to traction, you need to focus on the weight distribution and weight transfer. So please focus on to these things, keep on learning, keep on designing good vehicles. If you've got any question associated with the discussion that we have made today, please drop me a message on Instagram. We are available on Instagram with the name of ARC Global. You can also drop us a message on this particular number, +91 8800 219630. If you've got any question associated with the discussion that I have made today, you can just write down to me on this particular number. WhatsApp me your question. Thank you so much everyone for joining me. I have just given you the basic glimpse on how your vehicle is needed to be designed. So thank you so much everyone for joining me. Each of you who have filled the attendance sheet, you will be getting the certificate of participation within 1 week time frame. Once you receive the certificate of participation, I would request you people to please share your certificate on LinkedIn. We will be validating your certificate's validity on the LinkedIn itself. So thank you so much everyone for joining in. We will be coming up with more such sessions in future. We need your support. Give us a subscribe, follow us on Instagram, and spread this word that we are coming up with such kind of sessions every Monday. Thank you so much everyone.